Welcome back. We have now seen that a system of linear equations can have one solution or no solutions at all. But there is a third option, as you will see in this video. Let's have a look at this system here. We rewrite it as an augmented matrix, and as you have seen in the exercise, we can then row reduce it to this echelon form. You can see from the echelon form that the system is consistent. There is no row with zeros on the left of the bar and a non-zero number on the right. To investigate the solutions, let's first go to the reduced echelon form. You can check that this is the right augmented matrix. Now we can translate back to a system. Let's look at the three equations. The last equation is true for any choice of values of the variables. It does not give any information about the solutions. From the second equation, we find that x3 equals 3/2. The first equation gives a relation between x1 and x2, but it does not fix both variables. We can express x1 in terms of x2. So if we choose a value for x2, then all the variables are fixed. But we can choose any value we like for x2. It is a so-called free variable. We can describe the solution set as follows. x3 equals 3/2, x2 is free to choose, and x1 equals 4 minus 3 times x2. For example, if you take x2 equal to 0, you get this solution. If you take x2 equal to 5, you get another solution. If you take x2 equal to minus 1/3, you get yet another solution, and so on. This system of equations has infinitely many solutions. A consistent system of equations has infinitely many solutions if it has at least one free variable. As it turns out, you do not have to solve the system to find out whether this is the case. You can tell from the echelon form. Let me show you how this works. Suppose you reduced the augmented matrix of a system to echelon form. For the system I showed you earlier, we found this echelon form. Note that each column, except the last, corresponds to a variable. The following is true. The variables that correspond to a pivotless column can be chosen as free variable. In our example, the pivots are in column 1 and 3. Column 2 is pivotless, so indeed x2 can be chosen as free variable. All other variables can be expressed in terms of the free variables. These variables are called the basic variables. That means if you pick a value for each free variable, then the values of the basic variables are also fixed. I would like to end this video with a convenient way to rewrite the solution set, the so-called parametric vector form. For the example system, we found this solution set. Now think of the free variable x2 as a parameter. Let's call it s. Then we can write the solution set like this. We can rewrite the solution set in terms of vectors as follows. Check this for yourself. This representation of the solution set is called a parametric vector form. It is always possible to write a solution set in this form with a parameter for each free variable. The parametric vector form is often convenient in the context of geometry. For example, we can think of each of the equations in the system as describing a plane in three-dimensional space. The solution set of the system is then the common line of intersection of these three planes. The parametric vector form gives a parametrization of this line. Thanks for watching.